Okay, so here we are with Unit 2, Lesson 1. Unit 2, Lesson 2. So you do need to have your periodic tables out. It'll make your life a lot easier. If you look in your periodic table, you're going to notice that on the upper part, there's a key. This happens to be the element that they use as a key. A key is just explaining what all these numbers are for, right? So we already know C is the symbol of that element. Um, we're not really going to look at this right now. This will come into play later on in the year, what are called oxidation numbers. We are going to look at these numbers here, and specifically, we'll start with the first one. You'll notice that this is a decimal, and we're going to explain why the mass of an atom is not a whole number. It's a decimal because there are what we call isotopes. We'll talk about that later on. The most important one is probably the atomic number, which is for carbon is 6. And it's important in several ways. One, every carbon atom has to have an atomic number of 6, which means if it has an atomic number of 6, every single carbon atom that exists, no matter where it is, has 6 protons in its nucleus. Which means if it is neutral, it's going to have 6 electrons outside the nucleus. It's important that you understand that what makes atoms neutral is because they have an equal number of positively charged protons in the nucleus and negatively charged electrons outside the nucleus. That's an extremely important fact. You may want to write that down on the left-hand side of your page somewhere, or make big notes about that somewhere. Okay. The other thing is down at the bottom, the electron configuration. Now, the electron configuration in this particular case for carbon is 2, 4. Notice how if you add 2 and 4, it comes out to 6. That's because the 2 and the 4 are the electrons. Now, why are they separated by 2 and 4? Because this is based on the Bohr model of the atom, right? Now, let me see if I can get this drawing to work. I guess so. Freehand. Okay, so basically, here's the atom. Here's carbon's nucleus. It would have, in its nucleus, it would have 6 protons. And we're going to look at neutrons in a minute. But it would also have 6 electrons outside the nucleus. Now, they're not all together. Carbon has 2 energy levels, or orbitals, if you remember, if you go back to his model, which are basically those circles around the nucleus. The first one has 2 electrons in it. You can write the number 2, or you can write 2 E's. I know this is hard to see. The second energy level has 4 electrons in it, and you could simply write the number 4, or you can put down 4 E's around the atom in that level. That would be called the Bohr model for carbon. Now, we're missing one particle, neutrons. The third subatomic particle is called a neutron. How do you determine the neutrons? Simple. You subtract the mass number, round it to a whole number, and the atomic number. So you get 12 minus 6 happens to be 6. Now, it's just a coincidence that the protons and the neutrons are the same. They're not always the same. In fact, rarely they are. So you would have 6 protons in the nucleus, and you would have 6 neutrons in the nucleus. And by the way, these two terms, protons and neutrons, you may want to write this down, are called nucleons. And you see L-E-O-N-S. So the protons and the neutrons collectively are called the nucleons. They're found in the nucleus. The electrons are not nucleons. They are not found in the nucleus. So really, you should be able to write a Bohr model for the simple elements up to probably atomic number 20, which is calcium. So let's erase this, and let's see if we can make this move again. Maybe not. Okay. Why is this not working? Okay, here we go. Maybe not. Ooh. Okay. Oh, there we go. Oh, hello. Yeah, I didn't close that, did I? I think I did. Okay, let me get it back again. Okay, let's get back to that page. Sorry, this happens. All right, so let's take a look at this chart down here. This is something that you should memorize. you should be familiar with the three subatomic particles. A subatomic particle is simply a particle that's found in an atom. There are three particles that are found in the atom. There are more, but in chemistry we only talk about three: the proton, neutron, and the electron. The proton and the neutron, again, are called nucleons because they're found in the nucleus. Each proton has a positive 1 charge and has a mass of 1 atomic mass unit. An atomic mass unit is a unit that was made up by scientists. It's not something that you really need to worry about. So again, if a proton has a mass of 1 AMU, 10 protons has a mass of, well, 10. It's found in the nucleus. There's two ways to write the symbol, and the protons are the same as the atomic number. The neutron, which is also a nucleon, because it's found in the nucleus, has no charge. It is neutral, like Switzerland. It also has a mass of 1. Notice that protons and neutrons have an equal mass. Here's the symbol, how you would identify it, either by an N or an N with a 1 and a 0. The 1 represents the mass, the 0 is its charge. And you find it by subtracting the mass number and the atomic number. The third subatomic particle is the electron. It is outside of the nucleus, so it is not a nucleon. It has a negative 1 charge, and notice the word under mass is negligible, which basically means electrons have virtually no mass. So when we find the mass of an atom, we add up the protons and the neutrons. We do not include the electrons. So how do you find the number of protons? Electrons? It's the same as the protons if the atom is neutral. And for now, we'll consider all atoms neutral. We'll get into that possibilities later on. And this is just showing you that table O just gives you some of this information already. A couple of terms that you should be familiar with. The mass number, as we said, is the sum of the protons and neutrons. You add the number of protons and neutrons, that gives you the mass of an atom. And we'll go back later on and determine, well, if an atom has 6 protons like carbon and 6 neutrons, why is its mass not 12? Why is it 12.0 something something? And that's because there's more than just that that's taken into account. And we'll get into that later. This is a term that really confuses students. They ask you for the nuclear charge of an atom, and some people are going to say it has no charge, and that would be incorrect. Because you have to remember that an atom has two parts: the nucleus, which is positive, and then outside the nucleus, which is negative. So the nucleus is positively charged. So the nuclear charge is equal to the number of protons. So for carbon, its nuclear charge would be positive 6. However, the atom overall, which means the nucleus and outside the nucleus, is neutral. That's something that students get confused with all the time. And we talked about the term nucleons. Okay, so we're looking at now practicing calculating subatomic particles in different atoms, and you notice that it gave you the first one. It gave you chlorine 35. Now this number that if you see this, it could be either Cl35 or actually the word chlorine 35. That is not the atomic number of chlorine. That's going to be its mass number. Same thing here. Carbon we know is 6, so 14 is its mass. Now you're going to say, well, wait a minute. The carbon that we just looked at earlier had a carbon mass of 12. That's correct. This is a slightly heavier isotope of carbon. It's a different kind of carbon. Same protons, different mass. So, and again, if you go to the periodic table, what you're going to notice is that the atomic mass of carbon, the atomic number of carbon is 17, and its mass is 35. So it has 17 protons. If you subtract the mass and the atomic number, it's going to be 18 neutrons. The electrons will be the same as the protons. Atomic number is 17. Mass number is given, it's 35. Its nuclear charge is the same as number of protons, and that would be the nuclear symbol that you see there. Okay? Now, I'm not going to go through this whole thing here because, as you can see, having a little trouble with the computer, but we will definitely go over it in class. Okay, so that's the end of